Hi friends, see today we will be completing the sound chapter, that is part 3. In part 1 and part 2 we have discussed regarding what are sound waves, progressive wave equations, okay, and also lastly in part 2 we have discussed about the stretched string. Now in part 3 we will be discussing about open and closed pipes. In part 3, open and closed pipes, that is organ pipes. Okay, open and closed organ pipes. Now let us see what is meant by an open pipe and closed pipe, and let us find out some expressions for that one. See, generally closed pipe అంటే ఏంటి, అలాగే ఓపెన్ పైప్ అంటే ఏంటి? లెట్ us differentiate between this. See, closed pipe అంటే strictly speaking one end is closed and other end is open. One end is closed, other end is open. This is called as closed pipe. The same way in open pipe, if you see, both the sides are open. In the open pipe, both the sides are open. And make a note, in closed pipe, when you are performing the experiments with tuning fork, the closed end always forms node and open end always forms antinode. Closed end always forms node. Okay, already I discussed in part 2 what is node. Minimum displacement, amplitude 0, maximum displacement is antinode. Okay, now I have done one experiment also. So, and also I have given some properties also, distance between two successive nodes, two successive antinodes, node and antinode. Okay, so your node and antinode distance ఎంత అవుతుంది? lambda by 4. This is closed pipe length. The same way open pipe మీరు చూసినట్టుగైతే, for open pipe both sides are open, so antinodes are formed at the ends. Antinodes and in between node. So lambda by 4, lambda by 4. This is open pipe. I will use suffix as 0. So this is the total length. This is the total length of open pipe, and this is the total length of closed pipe. Now we will differentiate both these, the fundamental frequencies, harmonics and other things. So firstly I will do for closed pipe. Closed pipe fundamental frequency ఎలా వస్తుంది? Fundamental frequency for closed pipe. See, this one I will take it as n, and you know V by lambda or V is equal to n lambda is the formula for frequency. Now what is the length here? N is equal to V by, what is length? V is equal to n lambda. Lambda ఎంత అవుతుంది ఇక్కడ? Lambda closed is equal to 4LC. So here in the place of lambda I can write 4LC. Here LC means length of the closed pipe. LC means length of the closed pipe. Closed pipe length. I am using the suffix here. So this is the formula for fundamental frequency of a closed pipe. In the same way, if you go for open pipe, if you observe carefully, again V is equal to n lambda. Okay, open pipe I am using suffix, or V by lambda 0 is equal to n, or V by, what is lambda here? You can see here lambda by 4 plus lambda by 4. How much? Lambda by 2. So lambda by 2, open pipe. This is equal to length. Therefore, lambda 0 is equal to 2L0. Substitute here 2L0. That is the formula. So this is the fundamental frequency of open pipe. Parallelly I am deriving the equation so that we can save our time. So this is the fundamental frequency of open pipe. Compare with this one, closed pipe, V by 4L0. Okay. In the same way you can go for harmonics and overtones. You can go for harmonics and overtones. See here carefully. This is fundamental frequency. If you go for the next one, please copy this one. If you go for the next one, that is for example harmonics, second harmonic or third harmonic or fourth, fifth, so on and so forth. Let us try for this one. Okay, I will go for first overtone. Okay, we will see which harmonic it comes. We'll see which harmonic. See, always harmonic and overtones are related, as I told you, -1. Harmonic -1 always gives you overtones. But all the cases it won't become like that. For example, I told you in closed pipe it will be slightly different. Except closed pipe, in open pipes lo meeku em avutundante harmonic -1 cheste overtone vastadi. That is generalized. But in closed pipe it is not coming like that. It is coming in a different fashion. We'll see what happens. So for first overtone, we'll see which harmonic is coming for the closed pipe. Shall we? Right. Now I am going for the first overtone, that is, we'll see which harmonic it is coming. Okay. So I will go for first overtone. So first overtone and ela untundi okasari chudandi. In first overtone, I told you always closed and node ravali. Okay. So one more node will be coming here. That means I will shift little. Node, node, antinode. So this is for first overtone. We'll check up whether which harmonic it is coming, general or different. So node and node distance enta lambda by 2 from our properties, and this is lambda by 4. Lambda by 4 plus lambda by 2. What this is the total length now? This is the total length of the closed pipe. So what is the total length? Lambda by 4 plus lambda by 2 enta avutundi? Lambda plus 2, that is 3 lambda by 4. I am using suffix C. So 3 lambda by 4 is the length of the closed pipe. Now we apply here formula V is equal to N. I will put it as 1 into lambda. Lambda means how much here? 4LC by 3, or cross multiply 3V by 4LC is equal to N1. But what is V by 4LC? Fundamental frequency. V by 4LC and enti fundamental frequency. So em vachindi ikkada manaki N1 is equal to 3 times of fundamental. What does it mean? So this is equal to third harmonic. In closed pipe, first overtone is nothing but third harmonic. It is not coming. Second is missing. In general formula, what you are telling? N1 is equal to 2 times, 3 times, 4 times, like that you are coming. We have seen in the stretched strings. But here the second one is missing. Therefore, here first overtone, or it is also called as third harmonic. Okay? So that formula is not valid here. -1 formula here. So this is also called in closed pipe, third harmonic is equal to first overtone. Okay? Let us try for the second overtone. Second overtone em chuddam. Second overtone. Okay? Clear now? So we are getting some values 3 times. Here we are getting first overtone is equal to 3 times the fundamental. 3 times the fundamental frequency. Now I'll go for the next one. Okay? I'll try for the next one. Next చూద్దాం ఏంటది నెక్స్ట్ అది సెకండ్ ఓవర్టోన్ చూద్దాం ఒకసారి. సెకండ్ ఓవర్టోన్ ఏమవుతుంది చూద్దాం. యాజ్ యూజువల్ నోడ్ నోడ్ నోడ్. ఓకే, see here. So node 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 and antinode. So ఇక్కడ ఏం ఫామ్ ఇది సెకండ్ ఓవర్టోన్. సెకండ్ అవుట్రోన్ ఏమవుతుంది? lambda by 2, lambda by 2, lambda by 4. Lambda by 2 plus lambda 2 ఎంత అవుతుంది? lambda. So lambda plus lambda by 4. 4 lambda plus lambda ఎంత? 5 lambda by 4 is the length of the closed pipe. So ఇక్కడ నుంచి if you find again once again V is equal to, I will put it as N2 into lambda. From this ఎంత అవుతుంది? lambda 4LC by 5 or 5 times V by 4LC is equal to N2. జాగ్రత్త చూడండి ఒకసారి ఏమైందో. 5 times. So here it is coming as fifth harmonic. It is coming as fifth harmonic or second overtone. If you go in this fashion, you are getting ratio for closed pipe as 1:3:5. 5 is to 7 is to 9, so on, that is 11, 13, so on and so forth. That means what is happening to the overtone here? First overtone is equal to third harmonic ante ikkada ratio ela form avutundi overtone ki 1 plus 2 plus 2 plus 2 plus 2 in closed pipe. That means for nth overtone in closed pipe you will be getting in this fashion. We'll check cheddam. 2 plus 1 into F1 check cheddam. We'll check it whether it's right or wrong. 2 plus 1 into F1 where F1 is the fundamental frequency. Where F1 is the fundamental. Okay, check cheddam. Put n is equal to 0, you are getting F1. Okay? But I want what? First overtone. First overtone కావాలని ఏం చేద్దాం? n is equal to 1 పెడదాం. పెడితే ఏమవుతుంది? 2 1s are 2 plus 1 3. So 3F1 satisfying. So first overtone is equal to third harmonic. So it is satisfying this formula. Put n is equal to 2. Second overtone. 2 to the 4 plus 1. How much? 5F1 satisfying. Okay? In the same fashion third overtone. 3 to the 6 plus 1. 7F1. So it is satisfying. So this is the formula for nth overtone. Okay? 2n plus 1 into F1. Where F1 is the fundamental frequency of the closed pipe. Okay? And n is the nth overtone, which is equal to the harmonic. Because 2n plus 1 into F1 ఏమవుతుంది? Harmonic సమానం అవుతుంది. First overtone అంటే ఏంటి? Third harmonic. Put n is equal to 1. You are getting 3F1. So like this it satisfies the equation in the closed pipe. అంటే ఇక్కడ you are getting what? Odd numbers are getting. Even numbers are missing. Here you are getting 1 is to 3 is to 5. Odd numbers are getting. Even numbers అన్ని మిస్ అయిపోయి చూడండి 2, 4, 6 అని మిస్ అయ్యాయి ఇక్కడ. So that is the closed pipe. Clear? Now let us go to open pipe. We'll see what happens in that one. Open pipe lo ఏమవుతుందో చూద్దాం. ఓకేనా? We'll see what happens in open pipe. See, already in open pipe you have derived just one fundamental frequency. Entadi? V by 2L0. You can observe carefully. V by 2L0. In open pipe you have seen V by 2L0. Suppose if I go to first overtone కి వెళ్తాను. ఓకే, ఇది ఎన్నో హార్మోనిక్ కూడా చూద్దాం, చెక్ చేద్దాం. ఫస్ట్ ఓవర్టోన్ ఇది సాటిస్ఫై అవుతుందో చూద్దాం. సెకండా లేకపోతే ఇందాక థర్డ్ వస్తుందో చెక్ చేద్దాం. I'll go for the next one. When I go for next one, ఇది ఎలాగే యాంటీ నోడ్ ఉంటుంది. ఒకటి నోడ్లు రెండు ఫామ్ అవుతాయి ఇక్కడ మధ్యలో. ఓకే, నోడ్స్ రెండు ఫామ్ అవుతుంది. నోడ్ సో ఏమవుతుంది? ఈ విధంగా ఫామ్ అయ్యి ఒక లూప్ ఫామ్ అవుతుంది. అండ్ ఫైనల్లీ ఇట్ గోస్ లైక్ దిస్. సో యాంటీ నోడ్. So lambda by 4, lambda by 2, lambda by 4. Lambda by 4 plus lambda by 4, lambda by 2 plus lambda by 2 enta lambda. So length of the open pipe is equal to lambda 0. So when you apply the formula V is equal to N, I'll put it as N1 into lambda. Lambda అంటే ఎంత ఇక్కడ వచ్చింది? L0. లేదా V by L0 is equal to N1. Now for this one, I'll multiply and divide with 2. So when I multiply and divide with 2, what happens? 2V by 2L0 is equal to N1. But what is V by 2L0? Fundamental frequency. And ఏం జరిగింది? You are getting exactly. See, ఏమొచ్చింది మనకి? N1 I am getting as 2 times N fundamental. So this is second harmonic. First overtone. ఇందాక ఫార్ములా సాటిస్ఫై అయింది. ఏంటిది? సెకండ్ హార్మోనిక్ ఆర్ ఫస్ట్ ఓవర్టోన్. Here it is satisfying. Second harmonic, you see, N1 is equal to 2 times N. But what is N1? Frequency of the what here? First overtone. Frequency of the first overtone. Or it is also called as second harmonic. Then you can even try for one more. N1 is equal to 2 times N. So you can try one more. We'll go for one more. Inko try cheddam. Then we can write the ratio finally. And then we can go for nth also. So let us go for one more. Let us try one more. Okay. సెకండ్ ఓవర్టోన్కి వెళ్దాం. సెకండ్ ఓవర్టోన్, ఫస్ట్ ఓవర్టోన్, సెకండ్ హార్మోనిక్. సెకండ్కి వెళ్దాం. సెకండ్కి వెళ్ళి మిగతావన్నీ వేసేవచ్చు. సెకండ్కి వెళ్ళి ఆల్రెడీ యువర్ సీన్ హియర్ one node, second node, one more node is formed. Okay, see here, antinode, node, 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 and finally antinode. So this is lambda by 4, lambda by 2, lambda by 2, lambda by 4. Lambda by 4 plus lambda by 4, lambda by 2, and this another 2. So 3 lambda by 2. This is what? Length of the open pipe. దీంట్లోంచి 3 lambda 0 is equal to 2 lambda 2 into L0, or lambda 0 is equal to 2 by 3 L0. Substitute in the formula. I'll put it here. V is equal to, I'll put here for N2 for third harmonic, N2 into lambda 2 by 3 L0, or cross multiply 3V by 2 L0 is equal to N2. See what is 2V by 2 L0 again? Fundamental. So N2 is equal to నాకు ఏం వచ్చింది 3 times. So this is what? Third harmonic. Third harmonic. So if you observe this pattern in closed pipe లో మీరు pattern అప్లై చేస్తే see you are getting all the natural numbers వచ్చేస్తున్నాయి మొత్తం. ఎలాగంటే చూడండి, నెక్స్ట్ థర్డ్ ఓవర్టోన్, ఫోర్త్ హార్మోనిక్, ఫోర్త్ హార్మోనిక్, ఫిఫ్త్ ఓవర్టోన్. అంటే రేషియో ఎలా వస్తుంది మీకు? n/2, 2n/3, 3n/4, 4n/5 and so on. అంటే 1:2:3:4:5. So here you are having even and odd numbers also. In open pipe you are having both, where in closed pipe only odd numbers are there, even are missing. But in open pipe both even numbers and odd numbers are there. So if you go in this fashion, what is the nth overtone? Nth overtone ఎంత అవుతుంది? +1 +1 +1. Therefore you are getting n+1 into f1. This is the nth harmonic frequency. ఎందుకంటే what is f1 here? Fundamental again. Fundamental frequency of the open pipe. So ఇందాక మనం చూసినట్టుగైతే అక్కడ క్లోజ్ పైప్లో 2n+1 into f1, where f1 is the fundamental frequency. Here in this series +1 +1 +1 కాబట్టి you can check also n+1 into f1 లో put n is equal to first 1 పెడితే ఎంత అయింది? You can start with because ఇక్కడ చూడండి మనకి ఏమొచ్చింది, ఫండమెంటల్ ఫ్రీక్వెన్సీ మనకి చూసుకున్నాం. ఇదేంటి వచ్చింది? సెకండ్ హార్మోనిక్ ఆర్ ఫస్ట్ ఓవర్టోన్. ఓకే, సో హియర్ వాట్ యూ విల్ బి గెటింగ్ హియర్? చెక్ చేయండి. ఈజ్ ఇట్ n+1 or any other value? Please check it. Is it n+1 or any other value? Please check it. For open pipe nth harmonic n+1 వస్తుందా లేకపోతే ఇంకేదైనా వస్తుందా nth harmonic కి? Check it. ఓకే, see here. ఇక్కడ ఇందాక మనం చూసినట్టు కదా, ఒకసారి మళ్ళీ తీసుకుందాం. ఇందాకది 2n+1 f1 వచ్చింది మనకి ఎక్కడ? ఎన్క్లోజ్డ్ పైప్. సో అక్కడ నాకు ఫస్ట్ ఓవర్టోన్ కావాలి, n is equal to 1 పెట్టాను. అప్పుడు ఏడు వచ్చింది 3 times. సాటిస్ఫైయింగ్. n is equal to 2 5 times. సాటిస్ఫైయింగ్. సో ఇప్పుడు దేనికి ఫర్ ఎగ్జాంపుల్ నాకు ఫస్ట్ ఓవర్టోన్ సాటిస్ఫై అవుతుందో చూద్దాం. ఓకేనా? సో n+1 into f1 పెడితే అవుతుందా? విల్ చెక్ ఇట్. ఇక్కడ 1 పెట్టండి 2f1 అవుతుంది. సపోజ్ ఒకవేళ nf1 తీసుకుంటే nf1 ఎందుకంటే ఇక్కడ మరి జాగ్రత్త చూడండి ఒకసారి 1:2:3. వాట్ ఈస్ ద ఫండమెంటల్ ఇన్ ద ఓపెన్ పైప్లో? ఫండమెంటల్ ఏమొచ్చింది మనకి? V/2L0 కదా. దిస్ ఈజ్ ఫండమెంటల్. తర్వాత సెకండ్ హార్మోనిక్, ఫస్ట్ ఓవర్టోన్, సెకండ్ హార్మోనిక్ ఆర్ ఫస్ట్ ఓవర్టోన్. ఓకేనా? సో ఐ థింక్ దిస్ ఈక్వేషన్ సాటిస్ఫై. పుట్ 0 n is equal to 0 పెట్టండి. పెడితే ఎంత అవుతుంది? f1 ఫండమెంటల్ ఫ్రీక్వెన్సీ. n is equal to 1 పెట్టండి. n is equal to 1. 2f1 సెకండ్ హార్మోనిక్. n is equal to 3. ఓకే, n is equal to, ఎందుకంటే n+1 వస్తుంది చూడండి, 1+1 +1 +1. సో n plus 1 f1 చేస్తే n plus 1 into f1 చేస్తే దిస్ ఈజ్ ద nth overtone of the open pipe. In the other 2n plus 1 into f1 for closed pipe. Please check it here because there is a small confusion. Okay, so you need not confuse here. Here it is nothing but for open pipe n plus 1 into f1. F1 is the fundamental frequency of the open pipe. F1 into fundamental frequency of the open pipe. So these relations you can put it in the numerical problems while solving typical problems. అదొక మీకు ఎందుకంటే ఇక్కడ ఒకవేళ దీన్ని ఎక్స్పాండ్ చేస్తే nf1 ప్లస్ f1 వస్తుంది. ఓకేనా, అంటే బిఫోర్ ది nth అయినప్పుడు నెక్స్ట్ ది n ప్లస్ 1th అవుతుంది. n ప్లస్ 1th. క్లియర్? సో దిస్ ఈజ్ ద ఫార్ములా ఫర్ nth overtone n plus 1 into f1 for open pipe. And the ratio are 1:2:3. Here even and odd numbers are there, whereas in closed pipe only odd numbers are there, even numbers are missing. Please make a note. These are very very important in the examination point of view. Clear? Right. Clear? Now let us go after completing the pipes, open and closed pipes. Shall we do one small numerical? We will try to do a small numerical and give a problem. Okay. Right. See here a problem I am giving for you. For example, let us take some values 230 Hertz and 260 Hertz. So these are the two frequencies got. Okay, for example, for a closed pipe, for a closed pipe, for a closed pipe, for a closed pipe. Now he is asking you, what is the fundamental frequency of this closed pipe? What is the fundamental frequency? See, closed pipe lo meer chustunటే the ratio ఏంటి 1:3:5:7 అంటే n plus 2 plus 2 plus 2. ఓకేనా? సో సపోజ్ ఇది nth హార్మోనిక్ అయితే ఇది n plus 2 అవుతుంది కదా. Suppose this is nth harmonic, this becomes n plus 2. So what happened? N plus 2 into f is equal to 260. Okay, expand this one. nf plus 2f is equal to 260. ఇది ఎంత అవుతుంది? nth అనుకుందాం. అప్పుడు nth ఎంత అవుతుంది? n into f is equal to 230. So put that value here. 230 plus 2f is equal to 260. 2f is equal to 30, f is equal to 15 Hertz. So this is how you have to solve for a closed pipe. అర్థమవుతుందా మీకు? So this is the answer, that is n is equal to fundamental frequency in the 15 Hertz. Because ఇది nth అనుకుంటే ఇది n plus 2 అవుతుంది మనకి, because 1:3 కాబట్టి 5 వస్తుంది కాబట్టి +2. సో n plus 2 into f. అదే మనకి ఓపెన్ పైప్ అనుకోండి మారిపోతుంది, n plus 1 into f అవుతుంది, ఎందుకంటే అక్కడ 1:2:3 kabatti. So this is the fundamental frequency. So like this you have to solve the problems. Now let us go to the next item, that is beats. Very very important topic, beats. Okay, beats concept very very important regarding the examination. Beats ante enti? Okay na? Beats. See, generally beats can define like this. For example, n1 I will take 260 Hertz and one more n2 I will take 262 Hertz. That means when two sound waves, this is also called as interference of sound. This is also called as interference of sound, just like light. Light lo alage interference unna next chapter lo. This is also called interference of sound waves. So two sound waves having slightly difference in frequencies, okay, traveling in the media, same media, if they superimpose, the resultant is suddenly rising and falling. That is called as waxing and waning. That is called as waxing and waning. Waxing means rise and fall of sound. If you observe also, the graph will be in this fashion for the sound waves. Okay? It will be in this fashion. Okay, see? Maximum, here minimum. Maximum, again minimum. So, beats formation will be this fashion. Maximum at a time, t is equal to 0. Again, it will be minimum. Again, maximum, minimum. So, in that way, the beats are occurring. So, this is nothing but interference of sound waves. When two sound waves having slightly difference in frequency, traveling in the same media, superimpose, suddenly the sound rises and falls down. This waxing and waning of the sound is called as beats. Please make a note. There is small difference between beats and resonance. Resonance ki two frequencies should be same. N1 should be equal to N2, but it should be slightly different here. Resonance lo aithe rendu okate undali value 260 aithe 260. Beats kavalante slightly difference. You can see 2 hertz difference is there. Generally we will write N1 difference N2. Why difference I am writing? Because whichever is greater from that you have to subtract. So here what is the value? 2 hertz difference. So difference should be not very large. It should be minimum value. 2 to around 5 or 6. అంతకన్నా ఎక్కువ డిఫరెన్స్ ఉండకూడదు బీట్స్ ఫామ్ అవ్వు ఓకే సో బీట్స్ ఈజ్ అ వెరీ గుడ్ ఫినామినల్ ఇన్ నేచర్ అండ్ వాట్ ఈస్ బీట్ ఫ్రీక్వెన్సీ అంటే ఏంటి సి జస్ట్ నో ఐ టోల్ యూ నెంబర్ ఆఫ్ బీట్స్ అంటే N1 difference N2 కొట్టాం కదా సమ్ వాల్యూ పెట్టింగ్ నెంబర్ ఆఫ్ బీట్స్ produced per second, just like frequency. Number of oscillations produced per second is frequency. Number of beats produced per second is called as beats. So what is meant by beats? How many beats are produced in 1 second? That is called as beat frequency. Okay? Right. So what are the uses of beats? Generally beats ఉపయోగించి ఏం చేయొచ్చు మనం? What are the uses? Generally by using beats we can find the unknown frequency. We can find unknown frequency of a given tuning fork in the laboratory. Okay, in the physics laboratory, if any tuning fork is given for you, like this, okay, you can find the frequency by using beats. Very, very important. And sometimes beats are also used for tuning instruments. Beats are also used for tuning instruments. Musical instruments. And in rare cases, sometimes they are also use beats to detect carbon monoxide in mines, dangerous gas like carbon monoxide in mines. Okay, ఈ కంటెంట్ ఎంత ఉందో కూడా ఈ బీట్స్ ఉపయోగించి కూడా కనిపెట్టొచ్చట అకార్డింగ్ టు సైంటిస్ట్. బట్ ద మెయిన్ యూజ్ ఆఫ్ బీట్స్ ఈస్ టు tune an instrument and find out the unknown frequency of a given tuning fork. Okay, so these are beats. Now regarding examination point of view, they can give like this problems. Let us try one problem. For example, y1 is equal to numerical and 5 sin y1 is equal to 5 sin 600 pi t. Just I am taking an example, this one just for practice. 600 pi t, that is equation 1, and y2 is equal to some 4 sin 504 pi t, equation 2. Just I am taking an example, please, okay, to explain. 504 pi t. Now the question is, how many beats are produced per second? So how you will calculate such type of problem is there? Then simply you compare with the standard equation. Y is equal to a sin omega t. So in the place of, you can see omega t undi 600 pi t. T gets cancelled. Omega and 10 are 2 pi n. But here two terms are there. I'll take 2 pi n1 is equal to 600 pi pi cancel, n1 is equal to 300 hertz. So in the same way calculate for second one, 2 pi n2 is equal to 504 pi cancel, n2 ఎంత వచ్చింది, 2 1s are 225 2s are 252 hertz. Just I am taking an example. So n1 n2 వచ్చింది నాకు, how many beats are produced, either n1 difference n2 or n2 difference, whichever is greater you have to subtract. So therefore which is greater here, 300 minus 252, 48 hertz. అంటే ఇంత ఎక్కువ డిఫరెన్స్ రాకూడదు, జస్ట్ ఫర్ ప్రాక్టీస్ అగివే ఇంత డిఫరెన్స్ రాకూడదు. సో హార్డ్లీ విల్ గెట్ అరౌండ్ లెస్ దెన్ 10, మ్యాక్సిమం బీట్స్ ఆర్ లెస్ దెన్ 10 అండి, లెస్ దెన్ 10 beats per second. 10 దాటకూడదు, బట్ ఫర్ ప్రాక్టీస్ ఐఎమ్ గివింగ్ దిస్. ఎక్కువగా బీట్స్ అనేది విల్ బి లెస్ దెన్ 10 ఓన్లీ పర్ సెకండ్. 10 దాటకూడదు, ఓకేనా, ఇట్ విల్ లెస్ దెన్ 10 ఓన్లీ పర్ సెకండ్ నెంబర్ ఆఫ్ బీట్స్. మ్యాక్సిమం ప్రాబ్లమ్స్ 4 beats 5 beats 6 beats వస్తుంది, 10 దాటకూడదు, ఇట్ ఈస్ లెస్ దెన్ 10. సో దిస్ ఈస్ హౌ విల్ బి సాల్వింగ్ ద న్యూమరికల్స్ ఇన్ beats. Clear? Now after knowing about these beats and beats frequency, let us go to the next one, echoes. Echoes. What is meant by echoes? See, what is an echo actually? దీని తెలుగులో ప్రతిధ్వని అంటారు. ఎకో అంటే ఏంటి? ఫర్ ఎగ్జాంపుల్ what are the sources, first of all let us know. ఎకోస్ ఎక్కడ పడితే అక్కడ వస్తాయా, రావు. Where generally sources, what are the main sources? Near valleys, first one. Second one near wells. నూతుల దగ్గర గట్టిగా ఓ అరిచామనుకోండి, సౌండ్ మళ్ళీ మనకి రిపీట్ అవుతుంది. అలాగే వ్యాలీస్, నియర్ వ్యాలీస్, కొండల దగ్గరికి వెళ్ళి గట్టిగా అరిచామనుకోండి వస్తుంది. అలాగే థర్డ్ వన్ ఫార్ బిల్డింగ్స్, ఫార్ ఆఫ్ ద బిల్డింగ్స్, ఫార్ ఆఫ్ ద బిల్డింగ్స్. Sometimes when very superstructure is there, and around like 150 storage building, 100 storage building is there. If you go and stand beneath that building and shout loudly, you will hear the voice. So these are the main sources of the buildings, echoes. Now how an echo is produced, let us see. For example, this is a reflecting wall. Suppose if this is a reflecting wall, let an observer is standing here. Let an observer is standing here. Let the distance between the reflecting surface, wall or enclosure or any cardboard be d. Now when he is producing sound, it goes, hits and again comes back. So you know distance is equal to speed into time. Distance means enti velli malli venakku vachindi ante d plus d is equal to speed, that is velocity of sound. Here time is nothing but 0.1 second. What is 0.1 second here? That means the definition of echo. అసలు ఎకో డెఫినేషన్ ఏంటండి? when any observer is producing sound, after meeting the obstacle, if it returns back to the observer in 1/10th of a second, that is called as an echo. Echo అంటే ఏంటి? If any observer is producing some sound, after hitting the obstacle, if it comes back to the observer again in 0.1 seconds, that is called as an echo. So that is why the time I have used here 0.1. So 2d is equal to v into 0.1 seconds. But velocity generally will take 330 meters per second for calculations. So 2d is equal to 330 meter per second into 0.1 second. Second get cancelled. Okay. This point and this 0. So d is equal to 16.5 meters. So what is the minimum value here? 16.5 meters. Ante the minimum distance should be maintained between the obstacle and observer to perform an echo, to get an echo is 16.5 meters ఉండాలి. ఒక ఎకో ప్రొడ్యూస్ అవ్వాలంటే ప్రతిధ్వని గోడ కానీ అబ్స్టకల్ కానీ ఎంక్లోజర్ అబ్జర్వర్ మధ్యన దూరం ఎంత ఉండాలి? మినిమం డిస్టెన్స్ 16.5 కన్నా తక్కువ ఉండకూడదు. దిస్ ఇస్ ద మినిమం. మ్యాక్సిమం ఉంటే ఉండదు, దీనికన్నా ఎక్కువ ఉండొచ్చు. బట్ 16.5 కన్నా తక్కువ ఉంటే యూ కెనాట్ ప్రొడ్యూస్ అన్ ఎకో. దిస్ ఈస్ ఫ్రమ్ ద డెరివేషన్. Clear? Right. And what are the uses? Echoes యొక్క uses ఏంటి? What are the uses of echoes? See, generally echoes can be used for various purposes for scientific. For example, echoes uses. Generally Navy people Okay, like this is also called as a sonar. Sonar. What is the full form? Sound navigation and ranging. Generally, Navy people, what they'll do is, sometimes when the ship is completely submerged inside the water, so they cannot find out where the ship has gone. So they'll send the sound waves into the sea, deep level, and again the sound again reflected back. So by using that system, you can find the bed level of the sea. అంటే sea ఎంత లోతు ఉందో కనుక్కోవచ్చు by using echoes. అంతేకాకుండా when the aeroplane is going in some height above the ground level, you can find the height of the aeroplane. Second one, you can find the height of the aeroplane where it is flying by using echoes. Okay, and also you can find the velocity of sound by using echoes. You can also calculate the velocity of sound by using echoes. So these are the main important points regarding echoes. Adotna echoes use echo Navy people for scientific purpose to find the depth of the sea, bed level, and height of the aeroplane. You can find out, and also by you can find the velocity of sound by using echoes principle. Clear? Right? Now we are entering into the last part of the chapter. That is nothing but Doppler's effect. Very, very important. And from these questions are also coming. Last part, Doppler's effect. So this is given by a scientist called as Doppler. Doppler's effect. So what he's saying is, according to him, so according to this scientist Doppler, what he's saying is, let velocity of sound, velocity of source of sound, like any body, like bus or any aeroplane making some sound, velocity of the observer, all are going in same direction. Suppose ముగ్గురు ఒకే direction లో వెళ్తున్నారు అనుకుందాం. And if n is the frequency of the sound produced in air, if n is the frequency of sound produced in the air, so what does it mean? N waves it produced in 1 second, and one wave is produced in 1 by nth second, 1 by n second. So between any two successive waves, time lapse is 1 by n seconds. Between any two successive waves, the time lapse is 1 by n seconds. So if you go like this, I will get n dash is equal to n into v minus v0 by v minus vs. Okay, this equation is very, very important for Doppler's effect. అసలు Doppler effect అంటే ఏంటి? ఈ సైంటిస్ట్ ఏం చేశారంటే, when there is relative motion between source and observer, source అంటే who is producing sound, it may be vessel, any bus or aeroplane which is producing sound, that is called a source, and observer like we person, okay, who is observing the things going on. ఈ observer source మధ్య relative motion ఉండాలి, అంటే movement ఉండాలి. Suppose if both are rest, Doppler effect cannot be observed. So Doppler effect means the apparent change in the frequency of the source of sound, apparent change in the frequency of the source of sound observed by the observer when both observer and source of sound in relative motion. If both are rest, the apparent change in frequency will not be observed. That is what the definition of Doppler's effect. In this, we have almost 4 to 5 cases, very, very important cases. So here n dash means apparent change in the frequency. N dash means apparent change in the frequency of the sound produced by the source. Source and enti, it may be aeroplane, bus, okay, anything making some sound. N is the frequency of the sound. That means original frequency of the sound. V, velocity of the sound in air. V is velocity of the sound in air. V0, velocity of the observer, and Vs, velocity of the source of sound, like aeroplane, or bus, etc. V0, velocity of the observer, velocity of the observer. So these are the parameters first of all you have to give. Mari different cases ఏంటో ఒకసారి స్టడీ చేద్దామా? We'll see what are the different cases in this one. First one in the examination they will be asking many cases. అందులో 4 to 5 case important case ఉంది. Case 1 A bit ఏంటది? When source of sound in motion, see first one, source of sound in motion towards the observer at rest. Observer rest లో ఉన్నాడు, ట్రైన్ అబ్జర్వర్ వైపు వస్తుంది. అబ్జర్వర్ రెస్ట్ లో ఉన్నాడు, ట్రైన్ అబ్జర్వర్ వైపు వస్తుంది. అప్పుడు ఏమవుతుంది అబ్జర్వర్కి? అబ్జర్వర్ హియర్స్ మోర్ ఫ్రీక్వెన్సీ ఆర్ లెస్? He gets more frequency. Okay, practically. So what happens from this one? N dash is equal to N into V minus V0 by V minus Vs. Observers in observer rest lo unnaru kabatti V0 is equal to 0. And here I am telling a simple method to understand this equation. In maths we have numerator and denominator. In mathematics fraction we are having numerator and denominator. When you will get more value, when you will get less value. For example, numerator is more than denominator, you will get more value. If denominator is more than numerator, you will get less value. Here less value, here more value. I am telling an easy method to understand better manner for more and less frequency heard by the observer. Don't follow the sign convention here. Better you follow this one, you can easily derive the equations. So ఇక్కడ ఏమైంది? ట్రైన్ వచ్చేస్తుంది అబ్జర్వర్ వైపు, అబ్జర్వర్ రెస్ట్లో ఉన్నాడు. సో అబ్జర్వర్ ట్రైన్ సౌండ్ ఎక్కువగా ఉంటుంది కదా. సో మోర్ మీన్స్ వాట్? న్యూమరేటర్ షుడ్ బి గ్రేటర్ దెన్ డినామినేటర్. సో హియర్ ఆల్రెడీ దిస్ వన్ is 0. N dash is equal to N into V minus 0 observer at rest by V minus what should be Vs? Because numerator should be more than denominator to get more value. అప్పుడు ఏమో denominator should be less. అంటే Vs should be what? Plus Vs. Therefore plus Vs, velocity of the observer, I mean source. Therefore N dash is equal to N into V by minus into plus minus. So V minus Vs. చూడండి ఒకసారి, V minus Vs, V minus Vs. So V is greater. V is greater and ఏంటి? More frequency. Numerator is greater. So observer here the apparent frequency is increasing. So in this case what happens? Apparent frequency increases. Same way you can change. Suppose the observer coming here to the observer and receding away. Second case. Note చేసుకోండి ఇది. Second case. Second case అంటే the case 1లో B bit. Case 1లో B bit అంటే observer is coming towards the stationary observer. Source of sound is coming to the stationary observer and receding away. ఎప్పుడైతే ట్రైన్ ఇక్కడి నుంచి వెళ్ళిపోయిందో what happens? Frequency decreases. Okay? Frequency decreases అంటే అర్థం ఏంటి? Denominator is more than numerator. So what happens here? అన్ని ఎలాగే ఉంటాయి, ఇక్కడ ఒక్కటే మారుతుంది సింబల్. అంటే N dash is equal to N into V by V plus Vs అవుతుంది ఇక్కడ. Now denominator is more denominator means less value. So here frequency decreases, apparent frequency decreases. ఇందాక ఇంక్రీజ్ అయింది. So this is case 1 when the source of sound is coming towards the observer at rest and going away. Case 2 చూద్దాం మరి. Now let us see case 2. In case 2 ఏంటంటే now train is at rest, observer is coming towards the train. Okay? So second case లో A bit ఏంటంటే observer is coming towards the source of sound at rest. So source of sound rest అంటే Vs is equal to 0. Okay? V0 is in motion. So అప్పుడు ఏమవుతుంది? N dash is equal to N into V minus, we'll put the value this one V0 by V minus 0 because source of sound is at rest. Now see what happens here. In this case observe అంటే మనం ట్రైన్ వైపు పొద్దున మనం ట్రైన్ ఎక్కడానికి రైల్వే స్టేషన్కి వెళ్ళాం. ట్రైన్ అక్కడ ఆగిపోయింది. ఇట్ ఈస్ మేకింగ్ సమ్ సౌండ్. యు ఆర్ రన్నింగ్ టువర్డ్స్ ద ట్రైన్ టు గెట్ ఇన్ టు ద ట్రైన్. ఇప్పుడు మీకు ఫ్రీక్వెన్సీ పెరుగుతుంది కదా, యు ఆర్ గోయింగ్ టువర్డ్స్ ద ట్రైన్. సో అపరెంట్ ఫ్రీక్వెన్సీ increases means what? Numerator should be greater than denominator. Okay? So this should be greater means V0 should be minus. Okay? Therefore V minus, ఇక్కడ మైనస్ పెట్టేసేయండి, minus into minus plus V0 by V. See, so easy method. You need not follow the sign convention here. Just numerator and denominator you follow. That easily you can understand the subject. So you can show numerator is greater than denominator. V plus something. So here the apparent frequency what happens? Increases for the observer. Now same thing in B bit, for example, if the observer is receding away from the source of sound at rest. మళ్ళీ ఏమైంది, నేను ట్రైన్ ఎక్కడానికి వెళ్ళాను కానీ ట్రైన్ ఎక్కలేదు, కొంచెం ముందుకు వెళ్ళిపోయాను. సో వాట్ హ్యాపెన్స్ దెన్ అగైన్ ది అపరెంట్ ఫ్రీక్వెన్సీ డిక్రీజెస్. అప్పుడు ఇక్కడ ఏమవుతుంది సింబల్ n dash is equal to n into, in the place of plus you will get minus. In this case what happens? Denominator becomes more, v minus v0 by v plus v0. So here what happens? Decreases. So when the source of sound is at rest, observer is receding from away from him, then the sound again apparent frequency decreases. This is second case. Third case, please note down. Third case. See, in third case if you observe, suppose both are at rest. ట్రైన్ ఎక్కడో ఆగిపోయింది, సౌండ్ చేస్తుంది, మీరు ఇక్కడే ఉండిపోయారు, మీరు వెళ్ళలేదు ట్రైన్ వైపు. సో both there is no relative motion, both are at rest. Both are at rest means what happens? Third case, both at rest. Vs is equal to 0, V0 is equal to 0. Substitute in the formula. Apparent frequency n into V minus 0 by V minus 0. V gets cancelled. What happened? N dash is equal to n. So apparent frequency is equal to the natural frequency of the sound produced by the source. There is no increase or decrease in this case. ఈ సందర్భంలో ఇంక్రీజ్ కానీ డిక్రీజ్ ఉండదు, ఇట్ ఈస్ ఈక్వల్. దెర్ ఇస్ నో చేంజ్ ఇన్ ఫ్రీక్వెన్సీ బికాస్ దెర్ ఇస్ నో రిలేటివ్ మోషన్, బోత్ ఆర్ ఎట్ రెస్ట్. మీకు ఇందాక ఏం చెప్పాను, డాప్లర్ ఎఫెక్ట్ ఎప్పుడు చెల్లుతుంది? when the source and observer both should be relative, either should be at rest, another should be motion. Both at rest, no Doppler effect. Next, fourth case A bit. Fourth case ఏం జరుగుతుందో చూడండి. ఫోర్త్ కేసులో source of sound, observer both approaching each other. అంటే రైల్వే స్టేషన్కి వెళ్ళాం మనం, ట్రైన్ ఎక్కడానికి పరిగెడుతున్నాం, ట్రైన్ కూడా మన వైపు దూసుకుంటూ వచ్చేస్తుంది. అప్పుడు ఏమవుతుంది? ఫ్రీక్వెన్సీ ఇంక్రీజెస్ సర్టన్లీ, అంటే న్యూమరేటర్ షుడ్ బి గ్రేటర్. సో వాట్ హ్యాపెన్స్? n dash is equal to n into ఈ v మైనస్ న్యూమరేటర్ గ్రేటర్ అవ్వాలంటే v0 షుడ్ బి వాట్? మైనస్ v0 అండ్ vs ఏంటి? ప్లస్ vs. సబ్స్టిట్యూట్ హియర్ minus v0 by v minus plus vs. Therefore n dash is equal to n into minus plus v plus v0 by v minus vs. చూడండి ఒకసారి, numerator is greater than denominator. So here also again what happens? Increases apparent frequency when source of sound observe both approaching each other. ఒకవేళ both are receding, next b bit లో when both are receding అయితే ఏమవుతుంది? అగైన్ వాట్ హ్యాపెన్? ట్రైన్ ఎక్కడానికి వెళ్ళారు, మీరు ఎక్కలేదు, ట్రైన్ వెళ్ళిపోయింది, మీరు కూడా దాటిపోయారు ట్రైన్కి. సో వాట్ హ్యాపెన్స్? అగైన్ ద ఫ్రీక్వెన్సీ డిక్రీజెస్. అప్పుడు ఇక్కడ సింబల్ మారిపోతుంది, డినామినేటర్ గ్రేటర్ ఉంటుంది అప్పుడు. సో n ఇంటూ ఇన్ ద ప్లేస్ ఆఫ్ ప్లస్ మైనస్, ఇన్ ద ప్లేస్ ఆఫ్ మైనస్ ప్లస్, denominator is greater than the numerator. So here what happens? The frequency decreases. ఇది ఎప్పుడు? when source of sound, observer receding away from each other, receding away, frequency decreases. Clear? Right. Now last and final case, that is wind velocity. That means, for example, source of sound is there, observer is there, wind is also there. For example, same direction. నేను ఇప్పుడు ఇక్కడ మాట్లాడుతున్నాను, నేను నా డైరెక్షన్లో విండ్ ఉందనుకోండి, సౌండ్ ఇంక్రీజ్ అవుతుందా తక్కువ అవుతుందా? ఫర్ అబ్జర్వర్ ఇట్ విల్ బి ఇంక్రీజింగ్ because wind is in same direction. Now what is the relative velocity of the sound? It becomes more, v plus w in the same direction. So what happens then? n dash is equal to n into v minus v0 by v minus vs. Equation of the apparent frequency. When wind is in same direction, the apparent frequency increases because the relative sound increases, v plus w. So in the place of v plus w, again increase, but numerator should be greater. So v0 is minus v0 Vs is plus Vs. Substitute here minus V0 badalu minus V0 by again V plus W minus plus Vs. Therefore, apparent frequency heard by the observer is V plus W minus into minus plus by V plus W plus into minus minus. See here? In this case, the apparent frequency heard by the observer, listened by the observer, increases when wind is in same direction. Now suppose wind is in opposite direction. Source of sound ki wind opposite direction lo veltundi anukondi. Appudu konచెం frequency తగ్గిపోతుంది. Then denominator is more. So the apparent frequency is decreasing. So మళ్ళీ ఇక్కడ సింబల్స్ మారిపోతాయి అన్ని. అప్పుడు ఏమవుతుంది? n dash is equal to n into what is relative velocity? It becomes less now. V minus W. So V minus W, okay, minus what happened to V0? Here it becomes V0. Vs becomes minus Vs because denominator should be more to get decrease value. So appudu ఏమవుతుంది? Minus plus V0 by V minus W minus Vs plus lo minus Vs. So when you substitute here, what happens finally? See here what happens? The final equation apparent frequency is n dash is equal to n into V minus W minus into plus minus V0 by V minus W minus into minus plus. See here? So denominator is more than numerator here. So what happens then? The value decreases. So in this case, Doppler effect, the apparent frequency, when wind velocity is in opposite direction of the source of sound, apparent frequency decreases. These are the 5 cases, very very important regarding numericals, MSET and also NEET examination. Clear? Now, please try to understand the sound chapter is a very big chapter. We have covered many things from part 1, part 2 and this last part 3 chapter also. We have covered many things. So all the things you have to practice at home. Okay? All the things you have to practice at home. Clear? I think this is the final thing because according to your syllabus only, we are carrying, that means according to your regular syllabus, MSET syllabus, NEET syllabus and your IPS syllabus, whatever pattern I am telling you, according to your syllabus only I am telling, okay? So till now I think we have successfully completed part 1, part 2 and this one last one, part 3 also, okay? So all these, ఒకవేళ examination లో sometimes he may be asking the last one also, I will try to tell, that is rotating. Rotating source by observer. Rotating source by observer. Sometimes you may ask this one. అదేంటంటే ఫర్ ఎగ్జాంపుల్ ఇంతవరకు స్ట్రైట్గా వెళ్ళాడు. సపోజ్ ద సోర్స్ ఆఫ్ సౌండ్ ఇస్ రొటేటింగ్. లైక్ ఇన్ దిస్ ఫ్యాషన్. సో అప్పుడు ఇది వెలాసిటీ ఎంత అవుతుంది ఇక్కడ? సోర్స్ ఆఫ్ సౌండ్ ఇది Vs, 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 Vs. Suppose observer ఎక్కడ ఉన్నాడు? Observer. Suppose we velocity V0 అనుకోండి. So just now I given you equation apparent frequency n dash is equal to n into V minus V0 by V minus Vs. This is general equation or derivation for Doppler effect. Suppose the source is rotating like this in circular form. First is here, next is here, like this in a circular form. So rotate అవుతున్నప్పుడు ఏమవుతుంది? ఇక్కడ వెలాసిటీ చూడండి, అబ్జర్వర్ ఎలా ఉన్నాడు? పెర్పెండిక్యులర్. You can see is perpendicular 90 degrees. So what is the component of the observer here? Source. Vs cos 90, 0. So whenever he is perpendicular, you can see in the case of 1, 2, 3, 4. చూడండి 1 and 3 are perpendicular to the observer. 1 and 3, you can see this is perpendicular 90 degrees. So cos 90 0. Cos 90 0. So in these two cases what happens? ఈ వెలాసిటీ ఆఫ్ సోర్స్ ఎప్పుడైతే పెర్పెండిక్యులర్ వస్తుందో దాని కాంపోనెంట్ ఎంత అవుతుంది? కాంపోనెంట్ బికమ్స్ వాట్? 0. Vs cos 90 is 0, హారిజాంటల్ కాంపోనెంట్. సో 0 అవుతుంది కాబట్టి ఇది రెస్ట్లో ఉంటుంది కాబట్టి అప్పుడు ఏమవుతుంది? వెలాసిటీ చేంజెస్. Whereas if you see in these two cases, see, one is coming towards the observer, one is going towards the observer, away from the observer. ఇది towards the observer increases, going away decreases. మీకు అర్థమవుతుందా? See this one, this is towards. When the rotating source కానీ అబ్జర్వర్ రొటేట్ అవుతున్నాడు లేదా సోర్స్ అని రొటేట్ అవుతున్నప్పుడు ఇక్కడ చూడండి 1 and 3 are perpendicular to that one. Perpendicular అయినప్పుడు what is the velocity perpendicular? V sin 90 0. Sorry, V cos ఇది హారిజాంటల్ కాంపోనెంట్ కదా, V cos 90 0. హారిజాంటల్ కాంపోనెంట్ కదా, adjacent by hypotenuse. Adjacent by hypotenuse. So V cos 90 సున్నా కాబట్టి along this direction there is no component. So 0 velocity. సో ఈ కండిషన్లోని వెలాసిటీ 0 ఉంటుంది సోర్స్ది. కాబట్టి ఎప్పుడు మ్యాక్సిమం మినిమం ఉంటుంది? వెన్ ఈస్ గోయింగ్ అవే అండ్ కమింగ్ టువర్డ్స్. వెన్ కమింగ్ టువర్డ్స్ అవే అగైన్ ద సౌండ్ డిక్రీజెస్, apparent change in the frequency. Coming towards again it is increasing. So only in these two cases 2 and 4 during the rotation of the source the value will be decreasing or increasing depending upon coming towards the observer. అబ్జర్వర్ వైపు వస్తున్నప్పుడు ఏం జరుగుతుంది? ఇంక్రీజ్ అవుతుంది. అబ్జర్వర్ నుంచి వెళ్ళిపోతున్నప్పుడు ఏమవుతుంది? డిక్రీజ్. యాజ్ ఐ టోల్ యూ, ద న్యూమరేటర్ అండ్ డినామినేటర్ టెక్నిక్ కెన్ అప్లై హియర్ ఆల్సో. యూ కెన్ అప్లై ద న్యూమరేటర్ అండ్ డినామినేటర్. న్యూమరేటర్ గ్రేటర్ దెన్ డినామినేటర్, మోర్ వాల్యూ. డినామినేటర్ మోర్, లెస్ వాల్యూ. అంటే వెన్ ఈస్ గోయింగ్ అవే ఫ్రమ్ ద అబ్జర్వర్ వాల్యూ డిక్రీజెస్. సేమ్ కేస్ అగైన్, n dash is equal to n into v by rest position v minus vs. అలాగే n dash is equal to n into v by v plus vs. See here denominator more, denominator ఎక్కువ అంటే less, decreasing, going away from the observer. Okay, here numerator more, increasing towards the observer. సో ఇది కొంచెం ఇది హయ్యర్ లెవెల్ అండి, కొంచెం అడ్వాన్స్ లెవెల్. ఇది మనకి ఐపీ కన్నా కొంచెం ఎక్స్ట్రా. అంటే ఒకవేళ రొటేట్ అవుతుంటే అబ్జర్వర్ కానీ సోర్స్ కానీ అప్పుడు వాల్యూస్ ఏమవుతాయి? ఈ రెండు ఎఫెక్ట్ ఉండవండి, బికాజ్ ఇట్ ఈస్ పెర్పెండిక్యులర్. కాస్ వాల్యూ కాస్ 90 0 అయిపోతే ఈ రెండు ఎఫెక్ట్ ఉండవు. ఓన్లీ దీస్ టూ వాల్యూస్ టువర్డ్స్ అండ్ అవే. టువర్డ్స్ అంటే ఇంక్రీజింగ్, అవే ఫ్రమ్ డిక్రీజింగ్ అవుతుంది అపరెంట్ ఫ్రీక్వెన్సీ. ఆ రెండు కేసెస్లో ఇన్ దోస్ టూ కేసెస్ ఓన్లీ ద అపరెంట్ ఫ్రీక్వెన్సీ is increasing or decreasing. As you know, when the source of sound is coming towards the observer, increases. Going away from the observer, decreases. Clear? So these two things you have to put it in your mind. F maximum and F minimum. Okay, right? When the denominator is more, the frequency is minimum. The frequency is minimum here. You can call this one as minimum frequency. Minimum frequency. Denominator more. Maximum frequency. Maximum. Okay? Because you can see numerator is greater than denominator. Towards, going away. Clear? Okay. So I think this is the end of the chapter sound, first chapter in intermediate second year. Again we'll be meeting in the next chapter, that is light, ray optics and optical instrument. This is also called as geometrical optics. Okay? Right.